Hey everyone, hope you are enjoying Hashi Talks. So today we will be discussing on prevention better than detection, and we will be discussing Terraform unit test for security. How you can secure your Terraform scripts, Terraform code before going on a debugging mode. So yeah, hi, this is Neel Shah, a DevOps community guy. I work as a developer advocate at middleware, and I love to build communities in my local region. I also organize HashiCorp in my local HashiCorp user group in my local region. And I have attended more than 15 plus hackathons and have given talks in 10 plus conferences, including the KubeCon, PlatformCon, the Community Community, etc. So when prevention is better than the detection. Most of the breaches, as per the Gartner's report, that 90% of the cloud breaches is caused by misconfigurations. So detection is reactive, but prevention is proactive. So we need to detect and we need to test properly before it goes in production. So cost impact. If you see the amount of cost that fixing in production is more 10x expensive than fixing in development, you can consider how it can impact a business. So where actually Terraform workflow, that is code, plan, apply, and monitor, observe. So actually we can do testing properly. So it will be lesser cost and it will be lesser impactful. So you can do that in the code section. So before plan, you can have unit tests for security. You can also before apply, you can also have policy as code. You can use OPA or Sentinel. After apply, you need to monitor all the things and also threat detection. So this is a big scale. You can do that, but you need to apply the test cases at the code level. The shift left security approach. You might have heard the term shift left. It simply means that we bring security into the earliest stages of the software delivery process. For instance, infrastructure as a code, IAC, that means embedding security into your development workflow. We are not waiting for manual code reviews or cloud security scanner. Instead, our CI/CD pipelines runs automated unit tests for security every time when we commit. Similarly, you can set a proper observability. It will help you understand what went wrong, and so it will help you to gain more insights into your internal state of the system, and it will be more beneficial for you. Next comes, what are the types of Terraform security tests? First is static analysis. We consider linting and rule enforcement. So linting is basically we use tflint, tfsec, checkout, different sort of things. It will see how the patterns, how it matches, and also the syntaxes of the files. Next comes unit test, which will be we majorly focus this time. It will execute Terraform modules in a controlled manner and isolated environments. So there will be a different testing environment where all the things will be tested and it will be destroyed when the test is done. It will specify security requirements, and also we use Terratest custom. We can also use custom GPT, Golang or Python test cases. So Terratest is a Go-based hook directly into your. It directly hooks into your Terraform CLI and lets you set conditions on outputs and resource configurations. Next comes integration test. It runs against your deployed test environments, verifies your actual resource provider behavior, how it behave. And examples of this are InSpec. You will see as a simple example of that. Post deployment validation script also. InSpec is great if you want to bring a compliance as a core approach. Custom scripts work well when you have highly specific organizational security requirements. So these are the different perspective. Whenever you want to integrate security, you can use any one of them. Next is policy as a code. We will also see an example of policy as a code. It will enforce on the organization level and it will be there after you apply over there. So policy as a code is very much important for big organization to have proper security on every code bases which are going to production. So for this they have OPA, that is Open Policy Agent, and The HashiCorp also, they have a tool HashiCorp Sentinel, so you can also use that. So why unit test? For example, so go beyond linters. Just after validating, go to each and every aspect where the security can be breached and consider different things like it can also detect misconfigurations. It can also specify organizational rule policies. For example, you can write a test to assert that an IAM rule has only approved policies. That will be one thing because we don't know how many IAM approved are approved in our current provider, and we want that only these people can only touch the code. So we can apply that. We can also test that before going on that production. Apart from that, we as a human we generally ignore a lot of encryption. So every S3 bucket has encryption enabled so that no security no security fraud can be happen there. So you can also implement this sort of test cases via Terratest on S3 buckets, and you can also see if they are enabled or not. Also, you can also see the open ports. If 22 is not open to everyone, so everyone can inject anything and get your data over there. It will be also much very beneficial for you. Apart from that, we have network boundaries. So there are VPCs and security groups. You also need to check that, like from which portion inbound and outbound data flow is approved or not. See, here is a Terratest. It is for IAM role, which I was discussing previously in the previous slide, like how you can validate IAM role validation with Terratest. So Terratest, there we have Terraform destroy. So the role name prod read only. So only one only. So no one accidentally creates a privileged role in a production context. The role is only attached in this case to security audit. If someone tries to attach administrator access policy there, it will fail. The beauty of this approach is that we are testing the real Terraform output and not just that we think it will create. So we are actually trying out testing it properly with Terratest. It is very easy to integrate in your Terraform CLI because it is Go-based application sort of thing, which you can easily go on Terraform terratest.gram.io and you can easily download the. So how does the actually cycle works? Terraform testing deployment cycle. So the developer pushes code, the CI/CD pipeline is triggered, and the Terratest suits. It triggers the Terratest, and there are setup that it set up the Terraform environment and testing environment here. It will initialize, apply, and do the testing over there in a segregated environment, and it will clean the infrastructure once the testing is done, and it will generate a report. Once the report is generated, it will pass on the alerts and notification if the test was success or nothing, and if it is success, then it goes to production. You can see the whole diagram, the whole workflow, how it goes. The rich Terratest use case is the goal-based thing. Then it comes ISC approves, then only it goes to if Terratest are successful, then only it goes to prod. Otherwise, it won't. Consider an example InSpec, like I told about InSpec for encryption validation. So here is a sample code base for S3 bucket, whether it is encrypted or not. So one of the most common and dangerous misconfiguration in cloud environment is unintended public exposure. It's not just S3 buckets; it's open security groups, public subnets, load balancer without TLS. Because it should always have a TLS attached with that, so that after some time if you forget the passwords or something to place there, it directly gets vanished. Network boundary testing ensures that your Terraform code creates only the network exposure you intended. We can write test cases to check that no security groups has 0.0.0/0 on sensitive ports, like all the things are open there. The subnet default to private unless explicit mark otherwise. The load balancer and are internet facing only when justified. That great part is this test fail before any real infrastructure is preventing a public exposure from even reaching a staging environment. So this will test properly and it will be beneficial for us. This is a like structure of OPA, Open Policy Agent. You can see if someone has requested, then it will check out the whole policies, how it stores somewhere in OPA agent here. And similarly, if you go for HashiCorp Sentinel, similarly it also has a similar pattern. So you can consider if a policy input. See, the request is coming from a role who like person who has a role admin, and if the policy output also means that admin allowed is true for this request, then it will fetch out. Otherwise, it won't be given. Apart from that, scaling reusable test cases. Why this is important? Because we can create a lot of test cases for different use cases. So we can try to out for major general things like IAM roles, encryption. We can we can use them but recurrently. It will give consistency and it will also speed up the test casing sort of thing. It will also maintain a proper environment, proper version of that also, of test cases also. You can store them in some certificates or somewhere too. At least you also have backup of them. Auto centralize encryption checks. Encryption checks are always needed. IAM best practices, network restrictions, tag compliances. These are the major general things which are necessary for any organization to secure the. So, what are the best practices? Store test libraries in a shared Git repo or a cloud-based storage like buckets. Version your test packages and lock projects to known good versions because sometimes that also if that is incremented and then it will your test cases won't be fair thing in the end. You can also automate publishing to make updates easy to adopt. The tools mentioned here, the tool on the, the major of the tools are Terratest, InSpec, TFSec, Checo, LocalStack, OPA, HashiCorp Sentinel. So major of the tools you can use this for security purposes for your Terraform scripts. You can scan this code if you want to have a whole roadmap of Terraform. I've created this, it is on GitHub repo. And in case if you need some quick help with this, you can also connect with me on LinkedIn. Thank you. Hope you enjoyed this